So my name is Androwski Spicer. I'm a solution architect with Amazon Web Services. I've been with the company for a little bit over a year. I think a year and 4 months, actually. Feels like I've been here forever. Today with me is Jack Hemion and Usual Ratan, and these guys are both solution architects as well. So as you guys are aware, today I will actually be presenting on the core services of AWS, right? So we're going to be digging into Amazon's VPC. We're going to be speaking a little bit about EC2 and what actually pre-baking an EC2 instance looks like, right? When we talk about reducing the time to actually bring a machine up, that's where we actually install everything we need on a machine and then create an image from that machine that we can use as a part, for example, of an auto-scaling group, right? So we'll be talking a little bit about that today, and we'll be doing a few hands-on labs as well. So the structure of this presentation is that I'm going to go through each service, and then after each service presentation, we'll do a lab. So after the VPC segment is finished, we will do a VPC lab where we create a VPC according to Amazon's best practices. So can I see a show of hands of all who actually have AWS experience? OK. All right. And deep experience in terms of building production environments on AWS, or just getting familiar with the platform? No? Anybody who have advanced experience here? Yeah. OK. What do you hope to get out of this session today? OK. All right. So I hope I can present enough information to you. I'll also provide a few URLs at the end of this session that helps you to actually keep abreast of what we're doing at AWS. For example, what happens when a new service is actually released? Can you subscribe to actually get information on services as they're released? Yes, you can, and I will be providing this information for you. So again, I'm going to be introducing Amazon Web Services. Before I dive into the technicalities of the platform, right, and how you build secure environments on AWS, I'm going to talk about what AWS is and our approach to a global presence, right, and how that changes over time. I'll also be looking at networking, not just VPC, right, but just networking on AWS, and how you can leverage Amazon's VPC plus third-party applications within our marketplace to build an environment either as secure as your on-premise or more secure, right? And then we'll be looking at EC2 on almost everything EC2. So when we talk about bootstrapping your instance, when we talk about importing your instance into AWS, how do you do that? We'll be digging a little bit into that as well. I will provide it. I'll advise you guys if I will towards the end of this session. So AWS has been in the cloud business for about 10 years. We started in 2006, and since then we've actually grown to where we have multiple AWS regions across the globe. Not only that, we have over 1 million businesses actually running production workload on AWS in over 190 countries. When you talk about where we are, today we're in the United States, we're in Asia, we're in Europe, and we're continuously building out the AWS environment to satisfy, to bring our platform closer to our users and customers. So this year alone, we've actually launched several regions, actually. We've launched India, which is probably our latest region. We launched that region with 2 availability zones in it. And how we do things at AWS is that based on customer feedback, we continuously build out these regions and implement new regions as well. So why do customers are looking to AWS cloud instead of building out their own on-premise infrastructure, right? One of the reasons we see is actually cost, right? The ability to actually implement a server that fits your specific need, right, and be able to actually spin it down whenever that need goes away has been a huge benefit to our customers, right? Not only that, the scale at which we do business allows us to actually give you guys back, cost reduction as we reduce costs within our own environment as well, all right? So when it comes to, when we look at costs, we've actually reduced the cost of the AWS services to our customers over 50 times since we've actually we've actually launched AWS. And this reduction is actually not driven by customers or driven by competition. It's driven by us increasing efficiency within our environment and systems. And by doing that, we can actually give our customers back the benefits of that cost reduction. Now we look at elasticity. So when we talk about elasticity, we talk about the ability to actually grow your environment and shrink your environment on demand. And in many cases, without your intervention. And that's where services like Elastic Load Balancer and autoscaling come into play, right? Where you can actually build environments that scale up based on customer requests or just customer traffic or network bandwidth usage, right? And then scale it down when that goes away. Coupled with that are the instance types that we actually provide. We provide several different instance types that fit several different use cases or needs, right? And I'll dive a lot deeper into this as we go along. But one of the number one things at AWS, as a matter of fact, this is our actually number one priority, and that's security. Most customers can actually build in a level of security within the AWS platform that they can't achieve within their own environment at the cost that they can within AWS. So what sets us apart from the competition? And I think the number one thing is the amount of time that we've actually been doing this and the scale at which we now provide cloud services. The second thing is the service depth and breadth. When we started, we actually started with a few services, right? We started with S3, and for a while, that was what Amazon Web Services was. Today, we've actually grown from just providing an online object-oriented storage to providing several different services that fit within different use cases within IT. You can actually launch EMR workloads on AWS today. You can launch machine learning quite easily. You can launch practically any workload. So what we're actually seeing is that industries that were actually slow to adopt in the past are adopting AWS, right? And they're building out their infrastructure on AWS, extending their local LAN into Amazon. And we're finding in the past, it was sort of rare for a company to go all in onto AWS. But today, it's becoming the new normal, right? Most companies are moving their entire infrastructure into AWS. When you look at GE, you look at Capital One, those customers have realized the benefit of running within the Amazon cloud or within a cloud space. Third is the pace of innovation. One of the things that we live by at Amazon is that we start with the customer and work backwards. Over 90% of the innovation within our platform is actually driven by our customers, right? And because we're constantly getting feedback, we're constantly building new features and functionality within the AWS environment. I mean, just last year alone, we launched over 722 services and features within AWS. And since June of this year, we've actually launched over 368 new services and features, all right? And our customers love that pace of innovation because we're constantly keeping up and setting the trend within the industry. And then we look at the global footprint that we spoke about earlier, right? The ability to actually go global in minutes, right? And the whole concept here is, you can build an environment, and as a need arises to actually move that environment or expand that environment into another region, you simply create a template from what you already have and use that template to instantiate your new environment. So you're really building a complete replica of what exists within your production environment today into another region. And this is done quite easily. And we'll talk about how you guys can do that. And then we have the ecosystem of partners that AWS that we have today, right? We have partners that can actually help you to migrate your workloads onto AWS. We have partners that can actually handhold the process of building new applications on AWS, as well as we have our marketplace that has over 2,000 products within it today, right? So if you're, for example, if you're used to running your Cisco ASAs on premise, and you actually want that same look and feel within your VPC, you can actually launch a Cisco ASA from within our marketplace, and the license for that router is actually bundled within the EC2 instance itself, right? Do you guys have any questions? No? Okay. So I've been talking about regions, but what exactly is a region within AWS? A region is really a large geographic area in which we house multiple availability zones. And an availability zone can either be one data center or a cluster of data centers that are all separated by geographic distance. They're all on different floodplains, seismic planes, and actually power grids. So if something happened in one particular area, it will not take down a region that's located several miles away, right? And what that actually allows you to do is to actually build a fault-tolerant and highly available environment within AWS. Now, the beauty about the concept and the functionality of AZs is your VPC encompasses all the AZs within a region, right? So your VPC is actually agnostic. What that means is that you can have a subnet living in availability zone A and a subnet living in availability zone B, and the latency between both is single-digit millisecond latency. So they operate almost as if they're actually in the same data center, right? And everything is software-driven, it's software-defined, and as you guys will see later on, everything happens at the click of a button. So if you want to build a web server in AZ A, B, and C, it's just a matter of specifying the availability zone and the subnet and launching your instance within those data centers. Now, for every region that we launch with at least 2 availability zones in it. But you have some regions, like Northern Virginia, that has multiple availability zones. We're talking about 4 or 5 availability zones, right? So I mean, the ability to actually build a fault-tolerant environment there is, I wouldn't say endless, but it's a large advantage. So today, we have availability zones in Oregon, that's US West 2. We have it in Northern Virginia, that's US East 1. We also have it in Northern California, that's US West 1. We have GovCloud that is specifically built for government agencies and has met different industry compliance that government workload can actually run within those data centers. Of course, it's an isolated region unto itself. It's not necessarily connected to the broader AWS domain, right? So anybody have questions about that facility, we can talk about that a little bit later on. Now, I spoke a little bit about the service breadth and depth of AWS, right? But let's really look at what AWS is. At the core, we have the physical infrastructure. That's our regions and availability zones. But we have the services that everything else is actually built on top of, right? Let's look at EC2. EC2 is our compute resource, right? And EC2, you can actually find that behind multiple services. For example, EC2 container services, right? If you look at DynamoDB, right? The EC2 platform itself is behind a lot of AWS services. Not only that, we allow you now to actually build your own network environment within AWS that you can actually connect into, whether you're connecting into it via a IPsec tunnel, or you're actually extending your MPLS network into AWS, achieving low latency connectivity into Amazon, where Amazon now hangs off of your local network as if it was actually sitting in the same building. And then we have the database services. We launched RDS several years ago, and RDS has multiple database engines within it. Now, this is a completely managed service, right? It simply means that all you guys have to do is to worry about your database. Within RDS, we have MySQL, we have Oracle, we have SQL Server, we have MariaDB, and we also have our own flavor of database service called Aurora. And Aurora, I think of Aurora as more of a service where there's a lot more abstraction within the service itself, which allows you now to actually process data or process transactions much faster. It has a MySQL engine, right? But you're able to grow your storage, for example, elastically. You're also able to process more transactions than you would on a regular MySQL database. So what we see a lot is that customers who have Oracle databases look at Aurora and go, oh, this is providing the same enterprise type performance as my Oracle database, and it's much cheaper, right? And it's much more resilient because with Aurora, the replication, the backup is actually done for you. Now, at AWS, we actually prefer replication to backing up data. So when you look at Aurora, if you store, for example, a table that has the characteristics of a particular user, when you write data to that table, the data is actually replicated across multiple availability zones before we actually return a 200 OK message to you, right? And that happens outside of your knowing it. It happens automatically, right? The backing up of your data within RDS happens automatically. Once you specify when you're creating your database that you want to be backed up, you want it to be backed up at a particular time, we do that for you. So really, you don't necessarily need to worry about the maintenance of your database anymore, just the data you're putting into it, right? Then we look at analytics, where we have our data warehouse service, which is Redshift, right? And Redshift is our columnar data warehouse solution where you can actually implement Redshift clusters that can store petabytes of data. And again, this is a managed service, right? You're simply creating it for the performance that you need, and you don't worry about the management of it, all right? Within our analytics suite of services as well, we have Hadoop, where you can actually leverage Amazon's flavor of EMR to run your Hadoop workload, right? And of course, we try our best to actually keep on top of each release that comes out, so we try to be as current as possible. And of course, you have me. So for every account that signs up with Amazon or company that signs up with Amazon, you get a solution architect and an account manager. And the solution architect's job is to actually come in, sit down with your users or sit down with your IT team to figure out what your environment should look like on AWS and what are the best practices you should be following. Sometimes we're responsible for actually designing those environments for you and then helping you to actually get them launched.
Is there a cutoff for how many, like, when you get an account, like how big is that account? How many people do you need to be supporting on the network infrastructure?
That's a question that I can take offline with you a little bit later on. So do you guys have any questions before we dive into the technology itself?
Is there support to Spark?
Yes, we do support Spark. As a matter of fact, we try to we try to be as current as possible. So we're constantly releasing updates as Spark changes. Right. The beauty about Amazon as well is that you can take these open source technologies and integrate them quite easily with services, with managed services from like Redshift. For example, having your Hadoop cluster, crunching data, and pushing that out to S3 and using different functionality to automatically take that churned information and putting it into Redshift, right? So what we do is to actually try to alleviate a lot of the heavy lifting for you and make it as less manual as possible, right? And when we're not going to get into services like Kinesis or Lambda today, right? But when you look at these services actually grab your data. Once you configure it, it goes out and perform that function with you without you even having to click a button. And it can actually provide you with updates as it completes as well. So you know exactly what's happening. Networking and Amazon VPC. So what does a networking look like? Is anybody familiar or have deep experience with the Amazon VPC? Or before I begin, does anyone have a question around, a functionality or a problem they've had within the VPC? No? Okay. So within Amazon, we have 3 services that really make up our network portfolio, right? We have the virtual private cloud, we have Direct Connect, and what Direct Connect is that low latency network link or point-to-point link between your data center and your Amazon environment, right? Most customers today use MPLS links to actually get into AWS, right? Some customers are using sub-gigabit links, but we have many customers that have multiple 10 gig links into AWS, and they're load balancing across both of those links, sending traffic into AWS at single digit or to the double digit millisecond latency. And then we have Route 53, which is our DNS service. And we'll dig a lot deeper into what this is and how you can actually integrate that with your VPC to get resolution happening, split horizon also happening as well. So what is the VPC? The VPC is really a logical segmentation within AWS, right? So we basically carve out a piece of the AWS cloud and hand it to you. Now, once upon a time, right, you didn't necessarily have the ability to define a structure, a network structure that you want to operate by, right? A structure that grows or is designed to grow with your environment as your environment scales, right? What we've done in order to actually allow you to use the Amazon environment as a true extension of your LAN is to create the VPC. And the VPC allows you to define your master CIDR block, right? It allows you to define route tables and routes within those route tables. It allows you to actually define how your applications communicate within the VPC and also to the outside world, right? Which route is my application going to take to push traffic to users online, right? Or do I even want my environment to be accessible from the internet, right? Do I want a completely secured environment where none of my machines are actually accessible via a public IP address? Or how do I build an environment where I have somewhat of a DMZ or a service absorbing client requests, but my machines themselves remain in private subnets with private IP addresses, right? The VPC answers all those questions. It also provides stateful and stateless firewalls within your AWS environment. And everything we're talking about here are clicks of a button. Or if you're familiar with the CLI or you're a CLI-driven person, you can use a command line to build multiple AWS environments. So the primary components of the VPC is, firstly, your CIDR block. The CIDR block you define as with your local LAN determines how many servers you can actually implement within your VPC. The best practice for that is that when creating a VPC, you don't necessarily think about only today, but you plan for the largest amount of instances that you may want to launch, right? Because the last thing you want to do is to create a small VPC, and then you outgrow the VPC in a month and have to migrate everything within that VPC to another one that's much bigger, right? And we'll talk about some of the concerns and what success looks like and how to be successful within the AWS cloud. You can also define private and public subnets. Now, a private subnet is where you're not able to actually attach a public IP address to the network interface of these EC2 instances. So everything running within those subnets are completely isolated from the internet at all, unless you want to actually provide access to these resources via a NAT gateway or a NAT instance. And then we have route tables. Every VPC, once you create it, comes with a main router, right? But you have the ability to create multiple route tables and issue them out to your subnets as the need arises, right? So for example, if I have a VPN tunnel between my VPC within AWS and my local network, right? But I also have servers that must get internet access. I can actually have a public subnet where my public resources live in, and my private subnet where you can only communicate with those resources via that VPN connection. And those two subnets would actually have different route tables. So the private subnet would actually have a route table specifically for the router that sits on the edge of your VPC, right? The public subnet would actually have a different router. It would actually have what we call an internet gateway, and that's how you actually get out to the internet. And then we have the security mechanisms within your VPC. So security groups are really stateful firewalls. And what this simply means is you don't necessarily have to specify an access control list for allowing traffic in and out on a particular port. If I actually send a request out of my subnet to the internet, that's an open session, so the traffic has to come back, right? The difference with the network access control list that operates at the subnet layer, which is different from the security group that operates at the EC2 instance level, is that you have to specify access control lists to allow and deny traffic. So if I specify that I'm allowed to go out, I also have to build an access control list that tells the firewall to allow the traffic back into that subnet. And we'll actually get to what are the best practices for developing these firewalls or building all these firewalls. So what does success look like? The very first thing you do within AWS is to define the region in which you actually want to implement your VPC. The beauty about AWS is that we don't move your data outside of a region that you actually specify, unless you tell us to move that data outside of that region. So if you're worried about data sovereignty laws, right, that's how we get around that. We're not going to breach that for any customer unless a customer says to us, I want a multi-region setup, and I'm going to move data across multiple regions. The second consideration is, what is the purpose of this VPC, right? What resources am I actually going to run within this VPC? Am I going to allow internet traffic? How do I actually want that internet traffic to go out? Am I going to route that internet traffic through my own local network to get out? Or I'm going to open a internet gateway and allow traffic to go out via that gateway, right? And this all ties into security, right? Because if you have appliances on premise that filters that traffic as it goes out, then you may want to actually push that traffic through your local network. And some customers actually do that, right? Also, what kind of latency can my applications accommodate? Will a IPsec tunnel be sufficient? Or do I actually need a direct connect link between an AWS environment and my local LAN? And one of the most important things is, am I going to go with a /16 or a /28 or something in between? Now, the largest CIDR block you can define for your entire VPC on AWS is a /16. And that gives you over 65,500 IP addresses. The smallest is actually a /28. Now, again, once you define the CIDR block for your VPC, it cannot be changed, right? If your needs grow beyond what you've specified, you have to redesign your VPC, launch a new VPC, and migrate your applications over into that VPC, which is why from day one, you have to know what success looks like before you create a VPC. Or if you don't have a clear idea what it looks like, create the largest VPC you possibly can, right? And lastly, like any network, we follow industry standard network practices or protocols. So you can't have overlapping IP addresses. All right, so if you're going to design your VPC, you must know what CIDR you're going to apply to your AWS environment, because if you have overlapping CIDRs or IP addressing space between AWS and your local environment, we will drop that traffic at the gateway. And this rule goes along with pairing multiple VPCs as well. And we'll talk about what that looks like. Before I get into security, does anybody have any question? No questions? Okay. So again, at AWS, security is our #1 priority. If we are building a service and we found out that it's not secure, we are not going to launch that service, right? As a matter of fact, we have third-party companies who come in and actually do audits on the AWS platform, right, to find out if it's HIPAA compliant, for example, if it meets the SOC requirements, if it's ITAR compliant. So the AWS environment meets all these compliance regulations, right? Not only that, we provide you with the mechanisms and the tools within the AWS platform for you to build applications and build your environment to meet, for example, HIPAA compliance. So all the tools to actually help you to meet those industry standard compliance are actually within the AWS environment itself. One of those tools is actually the VPC security group, right? And the security group, as I said before, it's a stateful firewall that operates at the EC2 instance level. What this means is you can have a fleet of web servers for a specific task. And that task may be, I'm running an Apache web server that's allowing customers to vote, right? And you can have a security group that's specifically built for this fleet of servers. But you may have another fleet of web servers that needs to actually get access to a completely different set of ports than the servers that you have running. And you can build a security group that meets those requirements as well. So you can have multiple security groups within a VPC, right? And you can actually have multiple security groups assigned to an EC2 instance. Now, again, everything within AWS, right, is pretty simple. Everything you'll be looking at later on within the VPC lab is all going to be GUI driven, right? Where you're clicking to define what your firewall looks like. So everything is software defined here. Another thing that I should mention is that everything within the AWS environment is a REST API call, right? So we provide an extensive set of libraries or SDKs for different languages, Java, Python, Node, for example, PHP, Ruby. So if we have developers in the room that want to experiment with the AWS environment or build your own visual tool to interact with AWS, we provide the tool set for you to do that. Now, as I mentioned before, or as you can see here, the best practice is to actually not have one general security group with a bunch of ports highlighted and assigning everything to that security group, right? Your environment should look like this, where every application has their own security group, right? And the ports that they need to have open are the only ports that are open. And if you decide to open, for example, port 80, right? If you don't want the broader internet to have access to it, and you want a single subnet to only have access to it, you need to specify that subnet only. Because if you do that, we will automatically drop traffic coming from everybody else, right? Now, the network access control list, as I said earlier, operates at the subnet layer. Every subnet is assigned to a network access control list. By default, we're allowing outgoing and incoming traffic, right? Everything is allowed. But you have the ability to actually block communication between subnets within your VPC. Or if you've even identified an IP address from a region that shouldn't necessarily be communicating with your environment, you can actually add a rule to your network access control list that drops that traffic, right? Again, this can't necessarily be assigned to a single EC2 instance, right? It's only assigned to a subnet. And you have to specify allow and deny rules for it as well. So by default, when you create a VPC, your route table allows routing between every subnet within your VPC. But you may not want that, right? And this is how you actually achieve that isolation within your VPC. You can use the knuckles to actually tell us, what that subnet should be communicating with and what should not be communicating with that subnet. So you may have use cases where, you're a customer who says, you know what, I'm not going to build multiple VPCs, right? Every customer that I have, I'm just going to create a subnet for them, right? This is one way of actually isolating that customer within their own little bubble. Route tables. So what I'm actually doing here is just going through the core components of the VPC, right? And these are things that you must set up when you build a VPC. And we'll actually be going through that a little bit later on after this presentation. So within each VPC is an implicit router, right? What we call the main route table. So when you create your VPC, we create a main route table and associate all subnets with that route table, right? Unless you decide, you know what, I'm going to create a customized route table and associate a particular subnet with that route table, everybody will be associated with this. When you look in the console, you will not see the subnet association. As a matter of fact, you will see on the main route table 0 subnet association. That's because we implicitly associate those subnets with your route table. It's done behind the scenes, right? But you can explicitly associate a subnet with the main route table or with another route table. And of course, you can change which route table is your main, right? So what happens if I have a test scenario and I actually want to test an application, right? But I don't necessarily want to trouble my main route table. I can actually create a customized route table, create a subnet, assign it to that route table, and then test that workload within that route table. And when I'm comfortable enough, I move everything over onto the main route table. Now, the main route table will, in most situations, host your public subnets, right? So some customers, when they have applications that need to be isolated, that they want their on-premise users to actually have access to and nobody else, they may create a private subnet, create a customized route table, and add the necessary routes to that back to their head office, right? Whether that's going across your direct connect or that's going across your VPN tunnels. So how do I get out to the internet, right? Within the Amazon environment, you know, the structure of your network follows the traditional network. The only difference is we're not allowing you to actually lift equipment, right? You're not configuring a Cisco router for NATing, right? Or IPSLA, for example. You're simply just telling us, you know, what the gateway is and what should actually go to it. So within your VPC, you have a fundamental way to actually get to the internet, and that's through your internet gateway, right? And through your internet gateway, there's no necessary limitation on the bandwidth, right, that you have access to. This is not a single entity either, right? Your internet gateway is managed by AWS and is horizontally scaled. And what that simply means is, what if I have 10,000 servers, right, and they all need to access the internet, right? Can one simple single appliance or single entity within AWS manage that? No, we have to actually scale out to accommodate all those requests. But that scaling actually happens without you even knowing, right? So you're not seeing any difference in the performance of your network, your internet traffic, right? We handle all of that behind the scenes. Now, the only thing you do with your internet gateway is just to create it and assign, for example, default routes to it, right? So if you, for example, have a private subnet, and within that private subnet, you know, these machines need to actually pull updates from online, or they need to query a public AWS service, then you can actually create an internet gateway and a NAT instance, and a NAT instance will actually do the NATing that your router would do on premise for you, right? So all that functionality you can still get, but the only access to the internet will always be through your internet gateway. There's one thing I must mention as well. The Amazon VPC is strictly a IP version 4 network. We're not IP version 6 yet, right? And we'll let everyone know when that's available. We have customers asking for that. So what does a route look like in your internet gateway? Or what does a route to your internet gateway look like within your route table? And I mean, it's as simple as what you're seeing to the right, where you define where you're going, right, and what's actually taking you there. And if you look in the second row, you'll see IGW-ID, and that's how you know, is it an internet gateway, or is it a NAT gateway, or is it just an instance that I'm doing my own personalized NATing with, that I'm actually specifying to allow access to the internet, right? And that's it. There's no configurations besides that, right? And we'll go through creating internet gateways in the VPC lab and providing with access to the internet. The virtual private gateway. So we spoke about IPsec tunnels and access to the internet, right? But also spoke about, taking away the internet access from your private subnets altogether and allowing you to actually create a VPN tunnel to your local network. But what is that VPN tunnel going through? If it's not going through my internet gateway, how am I actually creating that tunnel? And the answer is that's handled by a completely different gateway altogether, right? So the entity that handles your public traffic is not the same entity handling your IPsec tunnels or even your MPLS terminations, right? And that entity is called a virtual private gateway. And the virtual private gateway allows you to actually extend one connectivity within AWS. You can build a dynamic IPsec tunnel, or you can build a static IPsec tunnel, right? Leveraging protocols like BGP, right? So again, the virtual private gateway is not a single entity either, right? This is something that's horizontally scaled and handled and managed primarily by us. And of course, you can create multiple virtual private gateways if you wish, right? When it comes to Direct Connect, you can actually have 5 virtual private gateways and have multiple interfaces going to these gateways from one single Direct Connect link. And we'll talk about that a little bit later on. Does anybody have any questions? It's quite a bit of information I'm giving. No? No questions? Okay. So, internet access. It sounds simple, and it is very simple, but it's easy for us to make mistakes, all right? In the lab, we'll actually go through defining routes for your public subnet and your private subnet to actually get to the internet. Now, you have the ability, as I said earlier, to route all your internet traffic through the internet gateway, right? But what we see companies doing is actually not doing that at all. They're not creating internet gateways at all, right, for their VPC environments. They're only creating virtual gateways, and all internet traffic is routed back to their head office and filtered before going out, right? So that way, you can actually take advantage of the appliances that you have on premise, the investment you've already made in that infrastructure, all right, instead of utilizing all of AWS software-driven resources. Now, when I just started networking, that's primarily my background. NATing was a fairly new concept to me, and there was a number of steps that I had to go through when doing it via a Cisco device, right? That's my expertise is within Cisco before I came to AWS. When I got to AWS and I saw how easy it was to actually implement a NAT gateway, I really don't have to configure anything. I can simply click on the gateway I want, and that's it. All right. But what if you actually want to configure that device? What if you actually want to configure your NAT gateway, your NAT instance, so that it's not only NATing traffic to the internet, but it's also establishing a VPN tunnel between multiple AWS regions. So you can pass traffic between multiple regions, right? So if I need high availability and I decide that everything that's written to my database, I want to replicate that to somewhere else, for example, or everything written to an EC2 instance, I want to replicate that to another region, you can actually launch a NAT instance, log into that instance, and configure it to perform this functionality. Of course, you would have to download the necessary tools on it to do that, but you have that ability, all right? So, I always tell people AWS is what you want it to be, right? If you just want it to be a push-button environment, it is. But if you want something that you can configure for specific use cases, you can also do that as well. And this is actually a diagram showing you customers who actually have an internet gateway for their DMZ and pushing traffic through that internet gateway, but they're also passing sensitive traffic through the VPN tunnel back to their environment and then up to the internet. Right. And in that instance, we spoke about this a little bit earlier. Now, the thing with NAT instances is that if you decide to actually launch your own NAT instance, you have to manage that, right? You have to manage the high availability of it as well. And you have to plan for the limitations of your NAT instance because you will be limited by the network interface that's connected to your instance itself. So if your instance has a limitation of 10 gigs, right, then you will inherit that limitation, right? So how do we get around managing the management of a NAT instance? How do we get around the network bandwidth limitations, right? What we did was to actually build the NAT gateway. And the NAT gateway is a completely managed component from AWS. And it provides all the NATing functionalities that you have known with a NAT instance, but we manage every aspect of it and take away that bandwidth limitation from you, all right? And again, a NAT gateway is not a single entity. It's actually a multiple services working behind the scenes to provide that NATing and keeping those NATed sessions going for you. Now, to building high availability with the NAT gateway, we recommend launching 2. So you have one in completely different availability zones. So if something happened to one availability zone, you will still have a NAT gateway going that you can add to your route tables, all right? So the high availability of it is limited only to a availability zone. But again, it's important to point out the power of the internet gateway, right? Because all of this traffic is still going via the internet gateway, right? So, every VPC has an internet gateway if you're looking to send traffic through Amazon Web Services. How many people have actually used VPC endpoints or heard about the terminology? No. Okay, so we constantly have customers coming to us and say, hey, we have compliance requirements where we need to access certain AWS services, but that request can't go through the internet. How can we achieve that? And our answers to those questions is VPC endpoints. And what VPC endpoints do for you is that it provides you with an interface inside of your VPC, but it also has an interface into the broader AWS network, right? Today we have VPC endpoints for S3, which means that if you want to send traffic to an S3 bucket in the same region as your VPC, that traffic doesn't traverse the internet anymore, right? It goes to a VPC endpoint, and then the VPC endpoint takes that and tunnels that traffic into S3. And there are different security mechanisms and access policies that you can now actually define how S3 and your VPC endpoint interact. So for example, if I have a fleet of web servers in a particular subnet, right, and all these web servers need to actually pull files from S3 and present that to my customers, right, I don't necessarily have to give or write an access policy within S3 for the broader fleet. I can write an access policy for my endpoint itself, and my fleet inherits that policy, and I can now communicate with S3 seamlessly, all right? And all of this traffic, again, is moving between different services without the access from outside. So nobody from outside can actually see that traffic going between your EC2 instances within your VPC and S3 itself. So it's contained within the VPC. So the VPC is actually agnostic to availability zones. So all availability zones live within a particular VPC. And that VPC is considered to be a single entity with its own addressing scheme, right? So what actually happens is the VPC endpoint, right, does a VPN tunnel through the AWS network to S3, sends the traffic back. So even through the VPC endpoint, you're getting security without even specifying SSL on S3 itself. So it's providing a lot of functionality under the covers for you. Yeah. And again, that traffic is not passing through any gateway at all. It's just passing to endpoints. And the endpoints themselves, like the internet gateway, like the VPN gateway, is not a single entity, right? And is not managed by you at all. And the beauty about it is that when you create an endpoint, the endpoint itself actually adds a specific route to the route table that you specify. And when packets actually hit your router for S3, it checks to see if this is actually going outside of region or it's within region. If it's outside of the region, it's going to go through your internet gateway. But if it's within region, it goes through the VPC endpoints. You can actually natively, for example, if you have an application running on premises, right, that you need to actually get access to VPC endpoints, natively that functionality doesn't exist, but I can walk you guys through how you can get that functionality. I designed a solution for that. So if you guys are interested in hearing about that a little bit later on, I can go through it with you. So what happens if I actually have a multiple VPCs, right? If I need to communicate with a vendor, and a vendor has a subnet within their environment for me that I need to speak to, right? What if I have multiple departments that have their own VPCs, right? And I need to talk to those VPCs within the same region. We have something called VPC Pairing. And what VPC Pairing does, it logically connects all VPCs that you want to talk to, right? What that simply means is I can say, you know what? VPC A, B, and C are all connected, and I can pass traffic between them as if they were all the same VPC. The latency doesn't change, right? So we're not it's not a physical connection. It's just a logical connection between multiple VPCs. So I can actually have Active Directory running in one VPC, right, and extending that to other VPCs, allowing my instances to be a part of that Active Directory domain. So basically what I'm saying is that you can actually have a management VPC and a VPC that hosts production and test environments, right? And you can connect those as if they were one solution. So we recognize that not everybody actually have the same level of networking experience, right? So we've created what we call the default VPC. And this sort of functions like the EC2 classic environment where you simply create an instance, and the instance has a private and public IP address, right? That happens within the default VPC for you automatically. So if you want to launch an EC2 instance and you specify the default VPC, everything you need to connect to that VPC is automatically assigned to the instance. So a public IP address is assigned to your instance, a private IP address is assigned to your instance, right? And you can actually establish connection to that EC2 instance without any further configuration or adding of route to a route table. The thing is, the concept of public IP address within AWS differs. So a public IP address is a temporary public address that's assigned to your instance, which means that if you destroy that instance, that IP address goes back into the pool. So what if I actually have two databases, right? And I have a public IP address on one database, and the other has a private IP address. And the one with the public IP address fails. I can't rip that IP address off and put it on the backup, right? How we get around that is that we provide you with what we call an elastic IP address. Elastic IP address is still a public IP address, but it's not assigned to an instance. It's assigned to your account. So you can actually associate it with an EC2 instance, take it off, and associate it with another EC2 instance. Does that make sense? Now, when you create an AWS VPC environment, just like your on-premise environment, it has to have DHCP, it has to have DNS. So all of this is created for you, right? So each EC2 instance that you create will get a private IP address. It has to have a private IP address, right? It will have a network interface that you can actually communicate with within the VPC. Not only that, what if I actually want to create my own, DNS service or DNS solution within AWS? You guys can do that, right? And you can do it to communicate with the default DNS service that we have, or you can bypass that, right? Again, it's quite a bit of information. Do you guys have any questions? No? Okay. So, Amazon Direct Connect. We've been talking a lot about Direct Connect, right? But what exactly is it? The more mature the VPC environment gets, is the more we recognize the need for lower latency. Not only that, if we have customers migrating applications within the AWS environment that cannot accommodate a specific high amount of latency, then we have to provide some way to help you reduce that. And that's where Direct Connects come into play, right? And Direct Connect really is just a cross connect from your equipment within your data center and AWS. Now, if you're running within an AWS partner's data center, you can easily cross connect into your VPC. But if you're not within an Amazon Web Services partner's data center, and you're in a data center that you have on premise, you can actually get a service provider like Comcast, CenturyLink, that does that last mile link into a partner's data center and then cross-connect into AWS. And there are trade-offs. So if you are inside a partner's data center, you can easily cross-connect at 1 gigabit per second or 10 gigabit per second. You can have multiple 10 gig links, right? If your pocket is endless and you want to pay for many 10 gig links, you can do it, right? If you're on-premise, you have the option to actually get sub-gigabit direct connect links, which means you're looking at anything from 50 upwards, right? 50 megabits per second upwards. The drawback here is that if you get a sub-gigabit direct connect link, you can only create one virtual interface into AWS. With a public, with a multi-gig or a gig direct connect link, you can create multiple virtual interfaces, which means you can have a virtual interface going to S3, you can have a virtual interface going to DynamoDB, and you can have virtual interfaces going to multiple VPCs, right? So we're basically taking traffic going to public services, putting them to public services, and taking your private traffic and splitting it off to your VPCs, right? Now, the good thing with Direct Connect is if you have a multi-gig or a gig link, and you decide, you know what, I have a fleet of servers in Northern Virginia, but my Direct Connect is only is actually terminating to Oregon, right? But I actually want to communicate with Northern Virginia EC2 instances. If these instances have public IP addresses attached to them or elastic IP address attached to them, you can actually build routes to these fleet of servers and communicate and send that backhaul traffic across AWS. So our fiber optic links, basically. And you can actually only do that within the United States. So when you look at Europe and Asia, you can't necessarily do that. But within the US, we provide that functionality. And now it's time for the VPC lab. So I will be providing free access to the Amazon Quick Labs environment, which means that everything that you spin up within that environment for this lab is not at a cost to you, right? You will need to register for the Quick Lab environments at the second URL, right? And then use the first URL to actually access the lab itself.